Hello, my name is Alexia Udol, and today I'm going to present to you Lab 2, Lines of Charge from Physics 2212. Lab Introduction. The purpose of the lab was to create a computational model in which the electric force between two charged tapes had to be calculated and estimate the charge needed for them to levitate above one another. This is the same experiment is being done as Lab 1. However, we are treating the tapes as lines of charge instead of point charges. The physics principles present in the lab are the force of gravity and electricity, which later on we will see that they should cancel each other out. The electric field, in which in this case we're going to be using the electric field of a rod, since we're considering lines of charge and not a point charge. And finally, Newton's second law. The preview of the results is that the lines of charge model is more accurate than the point charge model, and the Q obtained in the experiment is 2.61 e to the negative 8 C. The Q is obtained throughout calculations done with the electric field of the rod. Here are the calculations and the formulas. Here, as you can see, that instead of using the electric field of a point charge, we are using the electric field of a rod, which this is the equation. And we have to isolate Q in order to find the new Q due to the lines of charge. And here, as you can see, the electric force is basically the Q, the charge, times the electric field of the rod. Here we can see that these two forces cancel out, and we use Newton's second law to describe that the F net is 0. So we equate these two equations, and we are able to isolate Q, and finally we were able to get 2.61 e to the negative 8 coulombs. And here are other formulas that were basically the formulas that I just used to do the calculations in this lab. As I said before, we did the same experiment as of Lab 1, in which a charged tape was placed above another charged tape from a defined distance in order to calculate the amount of excess charge of the tape, and modeling tapes as lines of charge instead of point charges. Here is the GlowScript code. As you can see here, we have the physical constants. This mass was calculated in the previous lab. Also, here we see that we're using the Q that we calculated using the electric field of the rod, and here the electric field equation is placed, and also in this part of the experiment we're calculating the force on the top tape, which in this case is top B, and these in these places we are calculating the arrows and their magnitudes. Also, it's not shown, but in another part of the code, the distance between the tapes is 0.03 meters. Here are the results of the lab, and the assumptions that we can make is that we are assuming there are lines of charge instead of point charges, and that the charge along these tapes is evenly distributed among them. Air resistance is ignored, it's not really that important in this experiment, and we say that each U-tape has the same net charge, in which we can see that these two would cancel each other. The magnitude of the electric force is very similar to that of the gravitational force. What if you had modeled each of your tapes as a single point charge, like in the previous lab? When I placed in my previous Q of Lab 1, which was 1.4 e to the negative 8 C, there was a significant difference between the magnitude of the electric force and the gravitational force, indicating some source of error, since these two forces are supposed to cancel out. So why is this the case? These values differ because using the computational model of line charges gives a more accurate result of the forces acting on tape B, or the tape on top. This is due to the fact that we are taking into account all of the evenly distributed charge along the tapes instead of just one single point. This means that the charge exerted on tape B has to be greater than the charge exerted if it were a point charge. Thank you.